Everyone. So in this video, we want to not really learn anything new, but kind of use the stuff we learned so far on another example, which I find kind of interesting. And that is a Bendy flag pole. So we've looked at flags before, but this time, and it's a bit hard to see. So let's change the background. There is now a line and the flag, and we want the pole to be bendy. So what I did for that, so to save us a bit of time, I created a line here, and then I made sure that I have the points at the bottom in a pin group, and then all the primitives actually are in the group pole. And this is something I would recommend. Always use primitives to assign the different constraints. So then, of course, I have a flag with a planar patch. I turned red, and then I put this into a primitive group called flag. And we use those groups for a Vellum hair, and those are just the default settings when you create a hair configure. And then I put the pole into the group, and for the Vellum cloth, for the flag, I just put flag into the primitive group. And when I run this and I put this into a Vellum solver with default settings, then they're not connected, they just fall down. The only thing I created in the Vellum solver is a ground plane. Okay, so how do we put this stuff together? Well, first of all, we want to connect the two. And this time we don't have a static object, we have two active objects. The pole is an active object, therefore we can't use attach to geometry, but we use stitch. So whenever we want to connect two active elements in a Vellum solver setup, we use the Vellum stitch. So here is already the first things that are interesting. First of all, we have to, of course, say what is connected with what. Let's actually start with the pole should be connected to the flag. That would actually work and solve a couple of problems we might have later. The only problem here is that the lower points of our pole will be connected to the closest point on the flag. We can change this, of course, with the max distance. And then we increase that to something that makes a bit more sense. So maybe something like this. The disadvantage of this is that you have only connections where there is a point on the pole. You could switch that or change that with use closest location on primitive, because then every point on the pole will look for the closest point on the whole flag, which would work. And this could potentially be usable. The problem I see with this is that the topology of the flag does not match with where the points are attached. Now you could say it doesn't matter, and if it works for you, that's fine. But it tends to look a bit nicer if it's the points on the flag that are connected, and then kind of deformed around. So I would personally go the other way around and use flag to pole, flag in the geometry and pole in the target geometry. And let's actually go back to what we would get by default, and we see the same problem we saw before, that now every point on the flag is looking for the closest point on the pole geometry. Now, of course, we can limit this again with a max distance, but in this case I chose a distribution where this is a bit tricky, because what you get here with a distance of 0,02 is that you get kind of too many points on the flag. And if you lower this down, you have again the problem that some points like this guy here, or this guy, or let's see, this guy up here, they are not connected. Now, to be fair, this might be something you want. Maybe that is fine for you to have a kind of a couple of points not connected, which is again also an option. But let's say we wanted to have all the points that are near the pole to be connected. Then the quick solution for this is, again, the use closest location on primitive, because now every point on the flag is looking for the closest location on the pole. And this could actually be a pretty good solution. And the advantage to before is now that every point of the flag is actually constrained, and therefore you will have nicer deformations. Another option would have been that we don't use this max distance at all, but we actually use what's already built in with the planar patch. We could have said, okay, give me all the seam points of one of the edges, in this case this edge, and I'm not 100% sure. Let's assume it's the left seam, because unfortunately that's always a bit hard to see. What we could quickly do to test this is we could use a color node maybe. I mean, I'm sure there are other ways of doing this, and then I just use flag left, and yeah, okay, and this is the right 1, because as far as I know, there's no way of visualizing what group you just created. But left seam is the one we want. And now we could have gone into the Vellum stitch, and then instead of saying, okay, the whole flag should be connecting to the pole, we switch it to points and we choose the flag left, and now we have all the points connecting. Even without the max distance or use closest location on primitive, it will use all the points on the flag. And this now we can combine again with use closest location on primitive, and we kind of have the same result, just in another way. So it's up to you how you want to do it. But those are the options that come to my mind, at least. Okay, so what happens if I run this now? And this is the reason why I couldn't show you before the difference in the deformation, because when I run this now, okay, they are connected, which is great. Let's run this again. Yeah, they're connected, but they kind of instantly implode. Okay, what's going on? Of course, the flag pole is not stiff enough. So let's change that in the Vellum hair. And I chose hair here because it's a bit better for something that is actually pinned at some point. We could have used string as well, but hair is actually a good solution here for something, again, that has a connection at one end. So let's change actually the bend stiffness. So we go up here to 1, let's say, and let's go to stiffness of 100. And it's a bit better, but as we can see, it's still pretty problematic. So one solution for this could be that we lower the number of points on our pole. Now, this is the point where it was a good idea to use closest location on primitive, because that means it doesn't matter how many points we have in our pole here. If we lower this to, let's say, 10, we would still get the right connections in our stitch, which is why this option such a good idea. As you can see, it's actually exactly like it was before. And now, because we have fewer points in our pole, we should get kind of less strong bendiness, which is, kind of a cheat a little bit, but I still find that a pretty good solution for a problem like that. So let's actually go maybe to 20 on our line so that we can't see the solution too much later on. Now, of course, it's stronger, but it's a little bit better. Now, what else can we do? Well, we could think that we can increase the substeps, but this will actually not solve the problem, unfortunately. As you can see, it's still way too bendy. So what can we do? Well, obviously, as we know, it will not help to increase the bend stiffness even more. It doesn't matter. We can even put it to the absolute maximum and it will still not work. There you go. It seems better, but it's not. So the problem here is actually that the bendiness is kind of the maximum we could give it, or the bend stiffness, sorry, is actually the maximum we could give it. The problem here is that the mass of the flag is too strong and pulls the pole too much. So what we have to change here is actually the mass, so that the energy distribution between the two is a bit less on the side of the flag and more on the side of the pole. So in the Vellum hair, we can change the density to something higher, maybe 0.1. And in the flag, we can change it to something smaller, maybe this one. And this should actually already do the trick. And now it's so stiff that it doesn't bend at all. So actually, to give us our advantages back, let's actually lower the substeps again. Run this again. Yeah, so now it's fast at least. As you can see, our cloth is a little bit too stretchy. So let's quickly change this while we're here. And let's actually decrease the bendiness, bend stiffness, so increase the bendiness. And then actually, because it's a bit too extreme, let's decrease the mass on the pole again. And let's have a look how this behaves now. Yeah, much better. Yeah, not too bad. It's a good start. Now, the problem is currently we're basically, in a still environment. There's no wind or anything. So let's add this. We could add the wind here under forces in the Vellum solver. And actually, let's do this first with 3. And you can see now the bendiness is a bit too strong. So let's go back and actually increase the mass density again. I know I'm going back and forth, but that's just the nature of this. You have to find the right numbers, and that means you have to trial and error a lot. Let's actually increase the density to 1. Yeah, not too bad. So how can I make this even more? Yeah, okay, so the bend stiffness is already on a pretty high number. So now actually, now that we have wind, we have to increase the substeps again. Let's be careful, maybe to 3. Yeah, that's not too bad. And now our flag is a bit too stiff. So let's go into our vellum cloth and actually lower the bend stiffness even further. Don't be scared of doing this. It's totally fine to have a really low number here, if that helps. And you can see we have way more folds now, which I like much more. And this is actually not too bad. I could go higher with the wind here, but I would actually not use the wind directly in the Vellum solver, because the problem with that is it has no noise attached to it. So let's go actually and create our own wind. And of course we can do this in the dive target. So here in the dive target, we can create a pop. Well, we could create a pop wind, but the pop force has the same thing and a noise attached. So let's increase the noise. Let's add a force in one direction, maybe 5, and lower the swirl size to 0.5. And let's see what happens. Because I want to add a little bit of, turbulence to the whole thing. Yeah, that's not too bad. Let's actually increase that maybe to 8, the directionality. The only problem now, of course, is that the bendiness of our pole has increased. So we can do multiple things. We can further increase the density of our pole. And we can also increase the substeps, which is a good idea anyway, because it gives you a more correct result. But of course, you want to keep it fast. So I think I'll stop here. Let's kind of finish this by making our pole actually in a way renderable. And the one way to do this is we could just, from the output, use the group we still have and separate the pole from the rest and use a polywire on top of this. Or a sweep actually would be the more modern way. So let's turn this into a square tube and we increase the width. Currently I think the P scale is interrupting with our width, but that's fine as long as it works, because we have a P scale here. There it is. So you could increase the P scale instead of multiplying the width, but it comes out the same. So let's actually, I didn't want square tubes, I wanted round tubes. That's what I wanted. And now increase the radius. Still, the radius is a multiplier of the P scale. And this could give us, a pole. In this case, that's actually fine. You could think about, if you want, if your points are still too coarse, you could always do a resample before you actually render it to give it kind of an artificial post softness if you want. And if I lower the length here and then a sweep, you get a little bit more detail out of this if that's what you want. And then actually instead of a blast, in this case we use a split, because then we have the other end of our separation, and we can, which is the flag, and then we can merge those together. And this of course will look a bit nicer when we render this, because we can now control the thickness of our pole. And what you get out of this could look like something like this. So of course it depends on your case. So I increased the noise a little bit in my pop force, but my point is all the ingredients are here. You can, change the bendiness depending on your case, the wind force, the noise amount. It's up to you, but this is kind of how I would set up something like this. So, all right. So I hope this was helpful. Thanks very much and see you later. Cheers.